It has long been thought that the chemistry of our planet is unique. This was because studies looking into the composition of meteorites, which formed from the same gas and dust Earth was made of, found our planet had more of a particular isotope than anything else. But a new study has overturned this idea, by looking at different objects in the asteroid belt. This study found the objects have these isotopes in the same concentrations as Earth, which shows our planet is not as distinctive as we thought. The planets in our solar system formed from clouds of dust and gas, from which groups of meteorites called chondrites were also made. In the 4.6 billion years since the beginning of our solar system, the materials in these meteorites has generally stayed the same. This means the bulk composition of Earth should be the same as the rest of the materials that formed at the start of the solar system. But in 2005 this idea was put under question by findings that indicated materials on Earth had more of a particular isotope than meteorites. This abundance of neodymium compared with other chondrites implied the composition of Earth was different to that of the early solar system. Now a new study by researchers at the University of Western Ontario, London, Canada has looked into other objects, and found they do share a composition with Earth. The research, published in the journal Nature, looked at the abundance of the isotope neodymium-142 in some of the oldest solid materials formed in the solar system. The isotopes of Nd were measured precisely in 2005 but in different materials, the study's lead author Dr. Audrey Bouvier told Mail Online. The interpretation back then was that the difference between Earth and chondrites had to be the consequence of Earth's differentiation into different internal layers very early in its history. But the new findings show these isotopes are present in other materials, ones as old as the solar system itself. This means they must have been in the gas and dust that gathered at the start of the solar system, also known as the protoplanetary disk. We found that other primitive materials formed in the earliest years of the solar system and closer to the Sun also have the same composition as Earth, she said. The differences found previously were thus actually already present within the protoplanetary disk at the time of formation of Earth. Looking at isotopes of neodymium and samarium helps to pinpoint the evolution of materials in the solar system because one is stable and the other decays quite quickly. Nature has gifted us with a spectacular diversity of stable isotopes and of isotopes formed through radioactive decay, thus allowing us to place precise constraints on Earth's composition, said Professor James Day from the Scripps Institution of Oceanography at the University of California, in an accompanying article. The results have implications for our understanding of how the Earth formed, Dr. Bouvier says. The Earth evolved from materials that were different or in different proportions than the ones that built other planets such as Mars, she told Mail Online. It took longer than we thought for the Earth to form and evolve, but we find that both Earth and the Moon share more and stronger similarities with their building blocks and chemical evolution.